Hello. Today we're going to talk about 11.2 probability. Probability is the most commonly missed problems in all my math classes. In any section, hands down, people mess probability up all the time. Okay? Make sure you understand the words. Okay? Usually the people that understand probability are the stronger readers. There is a correlation. Okay? It's understanding what the sentence is saying. All right, so for number one, we have 60 vehicles in a parking lot. 15 are trucks. What is the probability that if I pick a random vehicle in the lot, it's a pickup truck? I get kids and people all the time that go, oh, well, I'm picking one truck out of 15. No, that's not how you do probability. It's the number of things I want over the number of total things. So what I want over the total. All right, there are 15 trucks I could pick and be happy with. Okay, there are also cars in there that I would not be happy picking. So I have 15 to choose from out of 60. So I have a 1 out of 4 chance of picking a vehicle that makes me happy, right? Getting a truck. That's what I want. That's my goal. All right. So, a softball player got a hit in 20 of her last 50 times at bat. What's the probability that she will get a hit in her next at bat? Well, she can get 20 successful ones out of a total of 50. That's 2 out of 5. All right, let's throw some vocab at you. A sample space. A sample space is the set of all possible outcomes to an experiment or activity. It's just, what are the things that I could get? What are all my options? Just list them all out. All right, if I have equally likely outcomes, that means each outcome in that sample has the same chance of occurring. Okay, it's nothing's, kind of biased or weighted. Okay, everything has the same chance of being of happening. Like flipping a coin, getting heads or tails is 50-50. Unless your coin is messed up, but we're not talking about that. All right. If a sample space has n equally likely outcomes and an event A occurs in m of those outcomes, then the theoretical probability is like the same thing as experimental probability. It's literally the same thing. Okay? So m is your total, and n has equally likely outcomes. Oh, I'm sorry. N is the sample space. So n is the denominator. M is the event happening. Okay? It's just the wording. That's what's different between experimental and theoretical. So in theory, what's the probability of getting a 5 on one roll of a standard number cube? Okay, that's just your SAT way of saying dice. Okay, so what's the probability of getting a 5? Well, there's 1 5 on 6 sides of a dice. Getting a sum of 5 on one roll of 2 standard number cubes. Oh, now this is different. Now we've got 2 dice. Well, I want to roll and get a sum of 5. So that means I could roll a 1 or a 4 or a 1, right? This is my first dice. This is my second dice. Then I could get a 2 and a 3 and a 3 and a 2. So there are 4 ways of getting 5. Now, total ways. Well, the first dice has 6 sides. The second dice also has 6 sides. think about it. This is what we did on 11.1, right? All of our options. That's 6 options for the first dice. So there are 36 total. So there is 4 ways of getting a 5 out of 36 total. So 1/9 is your probability. All right. Let's try it again. All right, pause it, give it a whirl. So we want to get an odd number. So let's see, what's the probability of rolling a 3? Well, I could get a 2 and a 1, or a 1 and a 2. So 2 options. Probability of a 5, you have 5, what am I saying? Silly me. 4 and 1, 1 and 4, 2 and 3, 3 and 2. I know we just did this. Probability of getting a 7. So we have, let's see, 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3. So that's 6 ways. Probability of getting a 9 is 6 and 3, or 3 and 6. And the probability of getting, oh, that's not the only way. 5 and 4, 4 and 5. That's a 4. Probability of 11 is 5 and 6, or 6 and 5. All right, so the probability of the ones I want would be 2 plus 4 plus 6 plus 4 plus 2. And my total ways was 6 times 6. So we get, what is that? 4, 8, 12, 18 out of 36, half the time. Which kind of makes sense if you think about it, right? But this is how we can prove it. This is how we can show our work. All right, let's talk about a deck of cards. A deck of cards is one of those things maybe not everybody has seen, but it comes up a lot in probability. So you might as well take the time to learn about cards. You can get a deck of cards at the Dollar Tree for $1. I can also show you them in class, so you can always ask me about them, but you want to know how a deck of cards is made up, all right, what it consists of. So the probability of getting a spade, well, that's a suit. There's 4 suits in a deck of cards. So there are 13 spades out of 52 cards, so 1/4. For each suit, there is a king, so there are 4 kings out of 52. So that's 1 out of 13. 1 out of 13, right? 1 king for every 13 in a suit. You can think of it that way too. Probability of getting a 4, that's just like getting a king. There's a spade, a club, a heart, and a diamond. Those are your suits. So there are 4 out of 52 cards. So 1 out of 13. And the probability of getting a black card, well, spades and clubs are both black. So that's 26 out of 52. So half the deck is black. The other half is red. All right, if you have any questions, please ask me. Probability is weird, and it's only going to get weirder, okay? We've got a lot more sections to cover, so please ask away. Make sure you got this.